In this video, we're going to be talking about absolute value equations. We're going to do two videos from this section 2.8. So here's the first one. So basically, we want to review what does absolute value mean. So absolute value means the distance from zero. So because of that, we measure distance in positive units. So that's why a lot of you remember absolute value as being only positive, which is mainly true. So we can obviously have negative values inside the absolute value, but again, this is just asking how far away is 3 from 0? So if we look at 0, we can kind of call that like our center. So the distance from 0 to 3 is 3 units. So that's why the absolute value of 3 is 3. The distance from 0 to negative 3 is also 3 units. So that is why the absolute value of negative 3 is also 3. So these distances are always positive. Okay, so now we're going to look at what happens if we have something besides just a number. We have an expression. So what this means is the distance from x to 6, that's the difference, that's why they're subtracting. The difference from, or distance from x to 6 is 9 units. So we know that can be 9 units to the right or 9 units to the left. So if we're the distance from 6, we're going to treat 6 as our center. Okay, so I want 9 units this way and 9 units this way. So 9 units this way is going to get me to 15. And 9 units this way is going to get me to negative 3. So that means x could be negative 3 or it could be 15. Okay, now that's kind of using a graph to solve. We can also solve this algebraically. Basically, we know that whatever is in the absolute value expression can equal this distance. Negative would be like going the left direction and positive is going the right direction. So whatever is in the absolute value, I'm just going to call it C, it can be an expression or just a single number, can be, if it's equals this, I can have C is equal to negative u or C is equal to positive u. Okay, so those are the two different equations we're going to set up when we're solving algebraically. Okay, so we're going to set well, first, I don't think we have an example like this, but I'm going to add in this direction. We're going to isolate the absolute value expression. Then set equal to both positive and negative values. Okay? All right, so let's take a look at this. So I have 2x plus 3. It's isolated. There's nothing in front of it or behind it that I need to get rid of first. So we're going to set 2x plus 3 equals 4. And 2x plus 3 equals negative 4. Okay, so now I'm just going to solve these two equations separately doing my typical algebra skills. So I'm going to subtract 3. So I get 2x equals 1, divide by 2. So x equals 1/2 is one possible place that would solve this equation. So if we plug 1/2 back in, we would find this to be a true statement. Similar to this one, we're going to subtract 3 and then divide by 2. So x equals negative 7/2 or negative 3.5. Again, if we plug this one in, we would also find that the distance is 4. So those are both solutions for this equation. So here's the part about isolating. So this plus 6 is not part of the absolute value expression, so we're going to get rid of it first. So I'm going to subtract 6. So I've got absolute value of x minus 4 equals 4. So now I'm going to set up my two equations. X minus 4 equals negative 4, and x minus 4 equals positive 4. Add 4. So x equals 0, and x equals 8 are my two solutions. All right. Okay, a couple more here, guys. This is another one where I need to isolate. So this plus 6 is not part of the absolute value. Now, we know that the absolute value is measuring the distance from a center. So this distance is always positive. So it is not possible to take the absolute value of an expression and result in a negative number. So there are no solutions to this. This is the symbol for no solutions, or you can just write out the words no solutions. So there's nothing I can plug in for x that would, when I take the absolute value of this expression, would result in a negative value. Okay, this one. we are going to set x minus 3 equal to the negative of this expression. So I want you to think about it as it's the negative of the whole thing. So I have x minus 3 equals negative 3x minus 5, okay? And then I also am going to set up x minus 3 equals the positive, so just as it is, okay? So I'm going to get my x's together on one side, so I'm going to get 4x minus 3 equals negative 5, add 3, so I get 4x equals negative 2, and I'm going to divide by 4, x equals negative 1/2, okay? Here I'm going to get my x's on one side as well, so I'm going to go the other way, so I'm going to subtract x, so I got 2x plus 5 equals negative 3. Negative 8 after I subtract 5 is 2x. So x equals negative 1/4. Okay, so you guys might notice this note up here that says extraneous solutions. When you have x's as part of this component too, it's a really good idea to check if your solutions work. So sometimes we'll get what's called an extraneous solution, which we get within the algebra process, but it's not actually a solution to the original equation. And again, this happens when I have x's inside the absolute value as well as the expression it's equal to. So I'm going to plug in negative 1/2. So I have negative 1/2. I'm going to check over here. Okay, so I'm checking, does negative 1/2 minus 3, absolute value, I'm checking, is that equal to 3 times negative 1/2 plus 5. Okay, so here I get negative 3.5. Absolute value is positive 3.5. Here I get negative 3.5 plus 5, which that equals what? 1.5. So 3.5 does not equal 1.5. So that means this is extraneous. It's an extra solution we got in the solving process, but it's not actually a solution to the original equation. Now, if we plug in 1/4, so I get absolute value of negative 1/4 minus 3. Is that equal to 3 times negative 1/4 plus 5? Okay, so here I get, I'm going to put it as a decimal here, you guys. Let's see, I get negative 3/4 plus 5. I don't think either of those work. Oh, found my error. Here we go. All right, so negative 3.5 is not what I get here. I get negative 3/2, which is 1.5. So I have these switched. Okay, so negative 1.5 plus 5 is 3.5. So this one is a solution. So when we plug in negative 1/2, that one works. There we go. Okay, so x equals negative 1/2 is a solution. We plugged it back in. We got it to work. Now we can see this one's not going to work. So I've got 3.25 equals, this is going to be 4.25 when I add those. So that's not equal. So that means this one is an extraneous solution. All right, so this is our only viable solution. This one's extraneous, okay? All right, write the absolute value for each graph. So what we need to do is we need to find the center of these 2 points and then the distance. So kind of here's the format. I'm just going to write this. I'm actually going to write this at the bottom here, you guys. So we got absolute value of x minus c. So c being the center. And then equals, I'm going to put d for distance. Okay, so that's the format we want to find. So the first thing you got to find is what is the center. So here I have negative 4 and 4, so halfway between those is going to be 0. So that's my center. That's my C. So absolute value of x minus 0 is just x. Okay, and then the distance is got to be 4, because it's 4 to each of those. So I set it equal to 4. So that would be the absolute value equation that goes with this graph. Okay, so sometimes our center is not 0, like in this case, so there's a distance of 6 between those. So 3 from either of those is going to be our distance. And then our center is 5. So we have x minus the center equals a distance of 3. Okay, here my center I can see is going to be -2. So c equals -2. And my d is equal to 1 on both sides. So x minus -2 equals our distance of 1. And then we can write that as x plus 2 just to simplify. All right, that is it for 2.5 day 1. Thanks for watching.